the Laplace transform of a function of t from first principles is given by the Laplace transform of f of t. So that is how we denote the Laplace transform of the function f of t. Are we together? So the Laplace transform of a function f of t is given by the integral from 0 to infinity of the function f of t exponential negative st dt. That is the definition of a Laplace transform from first principles. Meaning if you are told to find the Laplace transform of any given function from first principles, then you will be doing the integration. Are you seeing that? But when you are now told to find the Laplace transform of any function without them mentioning the word first principles, then you will be using the predefined formulas, isn't it? Because these predefined formulas of Laplace transforms, some of them are resulting from first principle, then the rest are an extension with the shift theorems. Are we together? So we now want to start with the first function. How do we get the Laplace transform of a constant? So Roman number 1. So you get the Laplace transform of A is what? The integral from 0 to infinity, our f of t is A exponential negative st dt, which is equals to what? A constant can be factorized outside, isn't it? So if you factorize out the constant A, you remain with the integral from 0 to infinity exponential negative st dt. How do you integrate an exponential function, isn't it? If you are integrating an exponential function, the first thing you have to check, the derivative of the inner function must be a constant, isn't it? Remember, here it is with respect to t, meaning t is the variable, so negative s is a constant, isn't it? Meaning if you differentiate negative st, which is the inner function here, you take negative s, that is a constant, then when you differentiate t, you get 1, isn't it? So it means when you differentiate negative st, the answer there is negative s, isn't it? So the inner function, what is the inner function of this exponential function? It is negative st. So if I differentiate negative st, I get negative s, because t is the variable. So if I differentiate t, I get 1. Negative s is just a constant, isn't it? So at the end, the derivative of an inner function is a constant, isn't it? So it means you can integrate that exponential function, isn't it? So the integral of that into exponential function, we have A. When you integrate an exponential function, it's a constant outside, it remains the way it is, then you divide by the derivative of the inner function, isn't it? That was resulting as a matter of the algebraic substitution, isn't it? Are we together? Then you divide with the derivative of the inner function, and the derivative of the function must be a constant, which is negative s in that case. If you differentiate, you get 1, isn't it? Then you put the limits of integration, the limits are from 0 to infinity. So infinity, the limit you can text the limit as b tends to infinity, then when there's infinity you substitute with b. Meaning that infinity is a very large number. So if you want to substitute infinity here, you just use a very large number. You test things like 1 billion, 1 trillion, you see it is telling you the same answer. Are you seeing that? Are we together? Yes. So from there you will get, you have negative s is a constant you bring outside, isn't it? So you have negative a over s. Then we remain with exponential negative st from 0 to infinity, because negative s is a constant you factorize outside, isn't it? And it is in the numerator, it's 1 over negative s. So we have negative a over s outside the bracket, isn't it? Then you key in the limits. So the upper limit is infinity. So when you put negative infinity, what does the calculator gives you? Just put exponential negative infinity, meaning negative of a very big number. Just put a very big number. Exponential raised to power. Don't put it in front of it, put it raised to, because of the kind of calculator you are using. So there. So you just put exponential raised to power, very negative, a very big number to represent infinity. Are you seeing that is raised to? If you put it in front of it, it means this is exponential 1, raised to power 1 times that. A very different thing according to that calculator, isn't it? Are we together? Yeah. So what do you get? If you use a very big number, 0. So it means as some value b tends to infinity and substitute infinity with b exponential negative b goes tends to 0, isn't it? So the upper limit is So we found it is negative a over s, then into the upper limit is 0, then lower limit minus. When you substitute 0 for the lower limit, where the 0, when you put 0, so everything will go 0 there. So you have exponential raised to power 0, isn't it? Anything raised to power 0 is 1. Is 1. So that is what you have. So here you have 0 minus 1, you get negative. See, inside here is 0 minus 1. See, that is negative 1. So negative 1 times the negative which is outside the bracket? Positive. So you get A over S. Have you seen that? So what have we noted? The Laplace transform of f of t, when it is a constant A, you just get A over S. Meaning a constant can be factorized outside. So it is like you are getting the Laplace transform of 1, isn't it? So the Laplace transform of 1 is just 1 over S, if it was 1, isn't it? Are we together? So the Laplace transform of any constant, meaning from this principle you've seen that the Laplace transform of any constant, if you now want, at least like, now you want the Laplace transform of 5. So you can see 5 is a constant, isn't it? So Laplace transform of 5 by predefined formula will now be 5 over S, because 5 is the constant A. Are you seeing that? Meaning if you want the Laplace transform of 3, it will be 3 over S. Laplace transform of K, if K is a constant, K over S, and you're done. Are you seeing that? So that is how to get the Laplace transform of a constant. Are you together? So that is how to get the Laplace transform of a constant. Because there are instances when you will be told from first principles, meaning you go the integral way, isn't it? But if you're just looking for the Laplace transform which is not from the first principle, then you are using the predefined formula, isn't it? You're using the predefined formula. Okay? Good.